Okay, so let's take a look at Scheme. Okay, this is the language that Bootstrap is based on, and quite frankly, the choice of Scheme is the most controversial part of Bootstrap. I mean, some people will say, "Well, we really like this, but really, Scheme," and here's why. Okay, so let's compare it to say Alice or Scratch, which we've looked at before. Compared to those, Scheme is actually a real programming language. Both Alice and Scratch have this feeling of, hey, I can do a lot of stuff really, really quickly, and then there's a brick wall that you run into also very, very quickly. Scheme has been used to write gigantic programs. I'm talking programs that would run hundreds of thousands of lines of code, which have been done in Scheme. We're not expecting our students to do that, but it is kind of comforting to know that if they learn this language, it can grow with them. Okay? Even if they move to a different programming language, the gap from Scheme to the next language is not that big. There is a gap, but it's certainly smaller than, say, the jump from Scratch to a regular programming language, or from agent sheets to a regular programming language. Of course, the other thing we can compare it to is a regular programming language. So why not use Python or JavaScript? Okay, so here are some reasons. Number one, Scheme is functional. You could actually count that as one of the drawbacks. Is a different style of programming, is one that is based on mathematics as opposed to, well, I don't know what the other ones would be called, but certainly not math, okay? In my experience, that actually makes it more accessible to beginning programmers. And that's because most languages are based on, here is a variable, and the value of the variable can change. And you have to reason, you have to think about how things change from moment to moment, and that's how we do programming. That's actually hard. Reasoning about change is hard. Thinking about change is hard. On the other hand, thinking about functions, here's a function that does this, here's a function that does that, that's actually easier, and it fits better with what students are already learning, for example, in math and science. Now, one thing that is really nice is that Scheme, even though it's this huge language, the way that it's used in Bootstrap, and actually the way that it's used in other systems that are geared towards beginning programmers. The obvious one here is something called Dr. Scheme. It's been renamed Dr. Racket, but the original Dr. Scheme and the current Dr. Racket, they have different language levels. So you have beginner, intermediate, advanced, and so on. And there's actually more levels than that. But what that does mean is that when you're a beginner, you get a smaller language to play with, which then grows as your abilities grow. And that's actually really nice because, for example, if you use something like Python, you may run into some of the corners of the language that are good for the advanced students, but the beginning students don't even realize, and it's like, oh my God, what just happened? Oh, well, to explain that, I'm going to have to teach you all these things to let you know what went wrong. You don't have to worry about that with Scheme. Here's something that's not good about Scheme. The syntax is weird. There's just no other way to say it. It is weird. On the plus side, it is consistent. So once you get past your original, what's going on, you're done. Okay, so it's weird, consistent. It's different. Okay, the semantics is very consistent. You kind of learn how it works, and it just keeps working like that. So when you learn a new thing, it's not here's a brand new concept for you to understand, the way it can be in some languages. Okay, and finally, the documentation is really, really nice. So if you're looking for a function that does something like this, you're very likely to find it, and that's great. Okay, so the students were going to be finding functions that you've probably never heard of, and there's thousands of functions, but it's easy to actually find what you need. Okay. Now, I do want to say this: the real benefit of Scheme is not the language, is the pedagogy that it has associated with it, and that's because of a group originally out of Rice University that built this framework for teaching programming called How to Design Programs. And it's got an amazing track record. It's been used in many universities as the beginning programming introduction to programming, and then and students have grown with it. Actually, and it's used right now at Northeastern. It's used in, like I said, it's a really cool way to introduce programming. It has been adapted to other languages. For example, Carnegie Mellon uses How to Design Programs, but they do it with Python, not with Scheme. Nice. The Bootstrap curriculum actually embraces how to design programs, and I think especially for middle school students, high school students, young college students, that is a great thing. This is really how you want to learn how to program. So here are some aspects of how to design program. The syntax is not important. That's not what we're going to focus on. That's one of the reasons that Matthias Felisen, who invented this, originally chose Scheme, because the syntax is simple. It is safe, which means that if you type something and it's a mistake, it doesn't do something totally unexpected. Okay, so that's part of their story. The real focus is not on learning arcane syntax. It is simply on, I have to understand what the problem is. This is more computational thinking. Somebody wants me to do this. What is it they want me to do? So the first step is to write a statement that describes each function. This function will do the following things. Be very precise. And then you need to try to understand, well, what kind of data am I going to need to do this? Like, for example, this function is going to compute my GPA. Okay, so it's going to need a list of grades, right? So that I can do that. Oh, sure, I can take the average of a bunch of grades. Wait, maybe they're weighted differently. So I'm going to need to get a list that contains a grade and this weight. And it's a list of grades and weights, and that's what I'm going to average. You need to know what kind of data it is your function will use. And then you need to provide examples of the computation. And the examples are not, well, the GPA of 3 A's and a B is 3.75. No, it's actually, the GPA is 3 A's and a B would be 4 plus 4 plus 4 plus 3 divided by 4. Okay, that's an example of the computation as opposed to an example of the final value. Okay, now the reason that it's so pedantic is that these pieces are meant to guide the programming process. So I know this of Matthias Felisen. He will tell his graduate students, when you're assisting people in the lab, when they come to you and say, we don't know how to solve this problem, ask them, so where's the concise statement that describes the function? And if they say, we haven't done that, go back. We're not going to help you. Go back and actually write that statement. Then maybe you'll figure it out by yourself. If you don't, by all means, ask for help. They come back. Here's the statement. So where's the data you're going to use? Well, we just want to get to writing the code. We don't want to. No, sorry, we're not going to help you. Go off and figure out what data you need. Then come back to us. So where's the examples, right? So you see what's happening here. Students actually have to go through this process. It's called the design recipe. And if they do, then most of the time they succeed by themselves. If they don't, we actually help them succeed. The statement describing the function ends up becoming the documentation for the function. This is a great thing. A lot of students, a lot of programmers, even professional programmers, write code, never write documentation. This is terrible, right? We don't like that. Particularly when we use somebody else's code and they don't have documentation, it is so hard. We don't want that. We have it at the very beginning with this process. The function is organized around the data. If I know that I'm processing a list, then I know exactly how to organize my code, because all code that processes lists looks like this. That's the recipe part of design recipe. Okay. I look at the examples and I use those examples to help me figure out what the program should look like. Okay, and of course later those examples become part of the test suite. This is something that we've emphasized a lot in computer science over the last 10 years, and that is write your tests first, then write your function. Is built into this process. So all of this stuff is actually the foundations of really good habits that are going to help the students later in their programming life. There is actually one more thing, and this is Bootstrap. This is not how to design programs. And that is the idea that beginning programs should be fun. Okay, they have to be fun. They have to have a wow factor. It needs to be something that makes people excited. For example, when I learned how to program, I wrote functions such as convert the degrees in Celsius to Fahrenheit. That is so boring. Okay, why would you want to do that? In Scheme, we might do. In Bootstrap, we might do something like write a function that tells us where a rocket is at a given time. And in fact, you don't have to write that. Okay, we will write this for you. But if you just write that one function that figures out after 3 seconds how far has the rocket gone, we'll show you a rocket ship that actually rises and does this. That's exciting. Okay, that's a wow factor. After people finish writing the program, they see a rocket ship in their screen actually going up towards the top. They don't get the feeling of, oh yeah, sure, I'm just converting, gallons to liters, or it's like that's boring. Don't do that. So that's what Bootstrap is. Okay, so let's say we're going to run Bootstrap. You have two choices for how to do it. Choice number one is to install Scheme on all your school computers. You can do that. It is entirely free. What you need to do is download something called Dr. Racket from this URL that's here on the slide. It's racket-lang.org. I want to say that Scheme is a real-world programming language. It was used in Dr. Scheme, which was the pedagogical introduction to programming. The languages have diverged a little bit, and Felison decided to cut the connection with the word so that people weren't confused. Oh, you're teaching Scheme? Like, no, I'm teaching them to program, not Scheme. So instead, he decided that a Scheme was a racket, and hence Dr. Racket. Now, option two. We don't need to download anything on your school computers. You simply run it from www.wescheme.org. That is similar actually to the Snap version of running it. This is like the difference between Snap and Scratch. This is also entirely free, so you can just download and go.